Hello class, in this video we're going to learn how to find the equation of a parallel line. The learning intention of this video is for us to quickly review how to find the equation of a straight line and then to learn how to find the equation of a parallel line. Because we know that the straight line is often written in the y equals mx plus c form, we have to first find out what the gradient is, and that is achieved by using the following formula. The next step is for us to find out what is our y-intercept value, what is the c value, and this was achieved by substituting a coordinate into the equation and then rearranging to solve for c. Afterwards, to get the equation, all we need to do was substitute our answers from step 1 and step 2 into the y equals mx plus c form to get our answer. This slide summarizes all the steps needed to therefore get the equation of a straight line. But if you're interested in finding out what is the equation for a parallel line, we still need to follow these following steps over here, but instead of using this formula over here to find out what is our gradient, we could already find out what is a gradient because if you recall, two parallel lines will have the exact same gradient. And as a result of this, if you know what the gradient is already, we could therefore move on to step 2 very quickly to solve for our y-intercept and therefore get the equation of a parallel line. Let me use an example to show you what I mean by this. So in this example, it reads, find the equation that is parallel to y equals negative 3x minus 5 and passes through the coordinate 1, 5. In this example, we know that the new equation should have the exact same gradient, so it should be equal to negative 3. So therefore, if I write the equation, we'll write y equals to negative 3x plus c. Now what we need to do is we need to substitute a coordinate in to therefore solve for our y-intercept. So therefore, if I substitute the coordinate that's given to me, 1, 5, this is what my equation would now look like. Now that I've got up to this step, what I'm going to do now is I'm going to rearrange to solve for c. So negative 3 times 1 is equal to negative 3. To solve for c, what I'm going to do is I'm going to add 3 to both sides of the equation, and in doing so, that's going to give me a c value that's equal to 8. As a result, my equation is going to be y equals to negative 3x plus 8. Let's quickly review over this example again. Remember, the first step was to identify what was the gradient of the parallel line, and we know that two parallel lines will always have the exact same gradient, so we just take the m value from the equation given to us. Afterwards, we had to find out what was the y-intercept, and the way we do this was substituting the coordinate that's provided in the question and rearranging to solve for c. Afterwards, what we need to do is substitute our answers back into the y equals mx plus c form to get the rule of the parallel line. Now I'd like you to have a go, so please give yourself 3 minutes to answer this question and we'll go through the answers together. So in this particular question over here, we know that the gradient is going to be equal to 2 over 3 for the parallel line. After we have done that, we need to now find out what is our c value by substituting the coordinate that's provided in the question. So if you have substituted 3, negative 4 into the question successfully, this is what your answer should now look like. What we need to do now is we need to simplify this equation. So 2 multiplied by 3 is equal to 6, and 6 divided by 3 is equal to 2. To get c by itself, we need to undo the 2 by subtracting 2 from both sides of the equation, and in doing so, c is therefore equal to negative 6. And lastly, we need to write our equation in the y equals mx plus c form, so therefore this is going to be our answer. What I'd like you to do now is I'd like you to have a go at answering question 3 from exercise 1i to get further practice. This is the end of the video. Thank you guys for watching, and I'll see you guys again in the next one. Bye.